Systems of equations. Plan is Q&A, ALA. How's it going, Aaron?
Very good. How about you?
Better than I deserve. Did you have any question about your test or about homework or anything?
Um, I was having a little bit of trouble with the doing the what's it called? The systems of linear equations with three variables.
Yeah.
But I mean, isn't that what the ALA today is about?
Yes, it's kind of that. That's what it's about applied. Uh-huh.
Okay.
Um, Let me address that. There's something that I kind of have a take on this, which is different. Might be helpful. So here's a system. Oh yeah, that is a system, not the one I was interested in. Okay, here's a typical system. Okay, and what I think is good to do is actually do it by substitution, which isn't necessarily something we think about with 3x3s. So here's a typical system, and we're going to go about it by substitution. And so that starts with solving one equation for one variable. And so what we're going to do is just take, we'll solve for y in the first equation. So add y to both sides and add 7 to both sides. And then we get 2x plus 5z plus 7, and that is y. And then we're going to substitute that whole thing in for y in the other two equations, which is going to reduce our 3x3 system to a 2x2 system, which of course is always the goal. When you're solving 3x3s. We get x plus 4 times this thing minus 2z equals 1, and 3x plus 2 times the thing plus z equals -7. Simplifying, that's going to be an 8x and a 20z and a 28. You'll have the minus 2z All of that equals 1. And clearing the parentheses here, 3x plus 4x plus 10z plus 14 plus z equals -7. Now, it doesn't seem like so much of a bargain yet. But of course, we are going to clean this up. And we have eliminated the y variable. So, let's see. We'll be able to combine these x terms in both equations. And z terms we also have constants there. And the form that we usually use is kind of like this form here. So we will isolate constants on the right side. So subtract subtract 28 from both sides, subtract 14 from both sides. And the system, our new system then is 9x plus 18z equals -27. Now, you look at that and you're like, all those are multiples of 9. So what's going on here? Could be something tricky on the part of the question writer. 7x plus 11z. Okay, that's not tricky. Equals -21. Okay. So now we've got, it took some work, but it wasn't hard work. And now we've got ourselves down to a 2x2 system. So maybe we'll go ahead and just exploit that situation with everything's a multiple of 9 in that top first equation there. Divide everything by 9. Which will give us x. So rewriting this equation right here, x plus 2z equals -3. And so then we'll solve this, not that, go away. This little system here. Okay. And we'll go ahead and use substitution again. Why not? On this little system right here. Subtract 2z from both sides. So, kind of in the meta, the goal of the substitution move was to reduce the 3x3 to a 2x2. And now our goal in the another substitution move on the 2x2 is to reduce it to a 1x1. Of course, if you solve a 1x1, you've got the solution to one of the variables, back substitute to get the value of another variable, and double back substitute to get the value of the last variable. X equals -2z minus 3. we will take this thing, throw it into the other equation for x, so that'll be right there. 7 times that thing plus 11z equals -21. So we'll just solve a linear equation here. -14z minus 21. Oh, it could be trickiness. Plus 11z equals -21. Looks like z is going to be 0. Add 21 to both sides, and the constant goes away. Combining these, it will be a -3z, which is equal to 0. Divide both sides by 3, and z is 0. Substitute to get x. X is -2 times 0 minus 3. First expression blown up, x equals -3. Then we'll take this equation up here and solve for y using that. So -2 or +2 times -3 plus 5 times 0 plus 7 equals y. -6 blow up 5 times 0 plus 7 equals y. Y is 1. We get, we believe, an ordered triple solution, -3, 1, 0. And a quick, mental check, make sure it satisfies all the equations in the system, which is, required to solve a system, is to find an ordered triple or the set of ordered triples that satisfy all the equations. -6 minus 1 plus 0 is a -7. Back, since z is 0, we can just mentally kind of block out all of that. -3 plus 4 equals 1. -9 plus 2 equals -7. So yes, this is the solution to the system. And we did it by substitution. We used substitution on the very first move that was used to reduce the 3 by 3 to 2 by 2. Make sense, Aaron?
Yeah, that makes sense.
ALA. So today we will follow the link, applying a solution of a 3x3 system. The login today is Breggy, Breggy. Give him some love. Okay, now here's some abstract looking stuff, but it's actually important and helpful. If a point xy is on the graph, then y equals f of x. Okay, it's on the graph of f of x, then y equals f of x. And it works the other way too. If you have y equals f of x, that determines a point on the graph xy. And when you read that, you think, okay, I'll buy that. Straightforward. But it's actually an extremely useful fact, which if you don't know it, and there are college algebra students that don't know it, then you're going to be in trouble. This is true of quadratic functions. If a point xy is on the graph of a quadratic function, f of x, then y equals ax squared plus bx plus c. If a point 2, 3 is on the graph of a quadratic function, f of x, then 3 equals what? Which is we know f is quadratic, and so what can we write? Right. So it might be useful to have a name for this form. We could call it from or okay. So here's a chance to use what we learned in the focus questions, which is always the point of focus questions, even though sometimes students immediately forget what they did in the focus question. we will simplify because we're going to reuse these equations. So go ahead and simplify the equations. While the system, needless to say, show all steps, take a moment to inspect the system before you start moving your pen. Which is generally a good idea. So we're in the rhythm of the substitution method, but that actually might not be so good. It actually could be if you kind of primed one of the equations.
Okay, sorry. My phone decided to restart for some reason because of an update,
Okay.
so I haven't been able to do things.
Yeah, no problem. Now, well, while you're working on that, we want to keep in mind the application. It says find a quadratic function that fits the data where x represents the number of years after 1980. So that's kind of the context of what we're doing. So are you still working on that, Aaron?
Yeah, I want to get rid of the 80 on the right and just subtract it.
Yes.
Okay, cool.
Yeah. And you can if you like substitution, it can be done with this. You'll take an extra step at the beginning. If you like the addition method, then you can totally do that too. So dividing by 5, aside from having to cringe at the thought of dividing an equation by a number, that's how you would do it because you can see what nice simple coefficients you get out of that. Twenty-four plus 27/2. So are you getting those simplified fractions from your calculator?
Yeah.
Mm-hmm. Math enter in a TI. Okay, awesome. So here's a model for this situation. Crude steel production in the US. It'd be interesting what the data would be after 1989. But you know, if the model, if we were to extrapolate and use the model, I don't know how accurate it would be. Extrapolation is always dangerous because the model was based on just the 80s, and to extend that beyond the 80s, you know, all bets are off. But, you know, we would put, you know, here it is 2024. That's 44 years after 1980. So we would have to substitute 44 for X there. And of course, Aaron, you mean X in that middle term. 44 there to get a prediction by the model about steel production in 2024. All right. Any question or comment?
No, I mean, I think the substitution was a little bit easier.
Good. Well, yeah, it's something that, you know, is going to work well for some students. Some are just diehard addition by elimination. Okay. But yeah, that substitution method, even on the first step on the 3 by 3, that's going to be a big win for some students. Okay, well, if there's anything else I can do for you, you know, just let me know. Stay in touch. And great work, great effort. And talk to you later.
All right, see ya.
Yeah, take care.